Hello, this is Matt Burrow. I'm presenting the Qubes OS architecture paper. The problem. The authors of this paper were concerned about the security problems facing current operating systems. The complexity of OS's designs, including wide variety of interfaces they offer, create a large attack surface. Once the kernel is compromised, the entire system is exposed, and an attacker has full access to any resource on the system. Even in user mode, an application flaw can still give an attacker access to all of the current user's files, and even more if the user has extra privileges. When a vendor patches a flaw, it does nothing to correct all of the other flaws in the system. And even if every publicized flaw was patched in an OS, there still exist unknown flaws that are ripe for an attacker to exploit, possibly on a very small scale against a very specific target. Qubes concept. Since virtual machines have strong isolation from their hosts and each other, the authors thought this would be a good way to isolate applications and parts of an OS from each other. Historically, the security boundaries in hypervisors have been very secure. This can in part be attributed to the much smaller set of APIs and services offered between the host and its VMs. Using hardware virtualization technologies not only increases performance of the virtual machine, but also further reduces the complexity of the host code, which can further increase security. It also allows some of the VMs to be used as host drivers and other code that interacts with hardware which would traditionally live inside of the kernel. To make separate VMs function as a unified desktop operating system, the authors created a secure GUI that allows seamless transitions between applications and provides the ability to transfer files and clipboard contents between VMs. Here's a sample screenshot from the Qubes site. The color of the title bar and the window frame indicate in which domain each application is running. The title bar also begins with the domain name in brackets. In the taskbar, a colored icon representing each VM also indicates the Windows domain, and in the tray, a colored outline can be seen around the networking icon to show its domain as well. Implementation. The authors chose to use the Xen open source hypervisor as the basis of their project. This choice seems wise because the alternative, the Linux KVM, seems like it runs considerably more code in the parent partition, which would be more susceptible to zero-day attacks. On top of the hypervisor, Qubes runs one administrative domain known as DOM0 to host critical code such as the GUI, as well as much of what would be in kernel mode in a traditional OS. The choice to run the UI inside of the administrative domain is an interesting one. On one hand, the authors point that if an attacker controls mouse and keyboard input, they have full control of the system makes sense. Still, GUI code is inherently difficult to write and get correct, so it seems this part of the code could be fairly susceptible to exploit. That said, DOM0 is designed to be excluded from all network access, so assuming the barriers Qubes sets up between domains are secure and its APIs are well designed, this should be less of an issue. To keep the network stack separate, all of the networking code runs in its own domain. This prevents an attacker from compromising the whole system if there are flaws in the NIC driver. Of course, if the NIC domain is compromised, an attacker could monitor all inbound and outbound network traffic. The author writes off this threat as unimportant, based on the idea that all network traffic would be encrypted, and the encryption and decryption would occur inside the VM hosting the application, not the VM hosting the NIC. This makes sense, but I think is a bit naive to assume users would ensure all traffic is properly encrypted. Like the network stack, the storage stack is also separated into its own domain. I think this is wise, as removable storage is a very common source of malware. Of course, this doesn't help to prevent against things like Office macroviruses that target the opening application, but it should cut down greatly on OS attacks from removable media. Finally, Qubes runs one or more application VMs to host the user's programs. I particularly like the suggestion by the author that the user could run multiple programs or websites in one VM as long as they share a common thread. For example, using one VM for all social media activity, since a compromise of one of these would often result in all of the user's online profiles being compromised. That should partially help address this problem. This comic, from xkcd.com, illustrates a point that has become more important as our computer use has migrated more and more to the web. Increasingly, our systems are used as nothing more than terminals to access our critical information hosted online. While the threat of a stolen laptop with one or more actively logged in web accounts is not addressed by Qubes. Using a separate VM for accessing your bank account than the VM used for viewing funny photos of cats decreases the likelihood of a keylogger or Trojan stealing your financial account credentials, assuming you don't reuse passwords. This image from the paper shows the logical layout of the VMs and the hypervisor. Note that the teal VMs on the right are running code typically found in kernel mode and rely on Intel VT-D to communicate with hardware. Networking. This figure illustrates the interaction between one app VM and the network domain. Again, all interaction with the NIC is performed directly by the network domain through VT-D with no interaction from DOM0. In fact, DOM0 has no network access at all. This is another view of the network connection from the paper. It shows how several app VMs would achieve access. The bridging of connections between app VMs is disallowed to prevent one from tainting the other. VPN Domain. Another interesting concept in the paper is the VPN domain. This is a VM that sits between the network domain and one or more app VMs to provide VPN access. In theory, a similar setup could be used for things like a firewall that is only applied to certain VMs as well. I like this concept because it allows individual VMs to be assigned to their own unique networks. A real-world problem I often face is the all-or-nothing nature of many VPN connections. There are times when I want some of my applications to be routed over my corporate VPN, but would prefer other traffic, like normal web browsing, to not incur the latency of a round trip to corporate headquarters. This design would eliminate that problem. Attack vectors. The author discusses two classes of attacks possible against their design. The first class is one stage, where a single exploit would immediately gain complete control over the system. The other class is multi-stage, where the attacker would need to first find a way to compromise one VM, and then find a way to use that as a jumping-off point to further exploit the system. The paper contains about 10 different potential avenues for attack, most notably direct attacks against the hypervisor, attacks against the GUI, and exploits against the storage and network drivers. The first two of these are one-stage attacks, while the others would be 2 or more stages to execute. Overall, the authors seem to have done a thorough investigation of attack methods, given that security research is their focus. One concern is that most of the types of exploits considered in this section are classes of defects originally discovered by the paper's authors. It is unclear if they did a thorough review of other researchers' work when considering possible attack vectors. Related works. I couldn't find any other research projects where one OS was comprised of individual VMs on the same system all working in conjunction, but there are several projects with similar goals or designs. First, Windows Steady State is a solution provided by Microsoft for Windows XP and Vista, which reverts the system to a fixed image at each boot. While this serves to prevent a virus from persisting on a machine, it does not prevent an exploit in one OS component from infecting the entire machine, even if it is only for that session. In fact, an attack that succeeds against one use of the machine would likely be able to succeed each time, as the base image being used remains constant. Still, this recover from image concept is used in Qubes as a means to recover a domain after it is infected. Next, Breaking Up is Hard to Do is a paper by researchers at the University of British Columbia, Citrix, and the NSA. It presents a similar concept of Qubes, but on a cloud hosting scale. The paper proposes Xor, which is a modified version of the Xen hypervisor. Xor splits the administrative domain into several separate VMs to reduce the possibility of VMs breaking the isolation between themselves and the host or other VMs. Finally, Citrix XenApp and more recently, Windows Terminal Services Remote App both provide the ability for an administrator to host an application on a remote server and allow users to seamlessly access the application as if it were running on their local machine. Both products provide the ability to remotely present audio streams and provide integrated clipboard and file system access. These features are very similar to the redirection described in the Qubes paper. However, the primary goal of both of these products is to decrease administrative overhead and reduce the number of software licenses needed in an organization, not to enhance security. Discussion questions. Consider these questions while discussing the paper. Does the shared clipboard and ease of moving files between domains compromise security? Do you agree with the decision to host the GUI system in the administrative domain? Do you think the Qubes concept would offer an improvement in security for a typical computer user? Consider that the user now potentially needs to patch multiple instances of an OS to keep all the VMs up to date. In which types of environments do you foresee this OS model working well? Thank you. I hope you've enjoyed this discussion of Qubes.